Okay, so this is 5 for special parallelograms, objective 1 and 2. Alright, so let's do the warm-up. If a quad math is a parallelogram and measure of angle A is 90 degrees, what can you conclude? So this is what it's asking. So let's see. Math. If this is 90 degrees, what can you conclude? You have the answer? Well, if it's parallelogram, the opposite angle should be congruent, but also the consecutive angles are supplementary, so this should be 90 degrees, and opposite angles are congruent. So if one is 90 degrees, then all is 90 degrees. That's the first one. And I want you to think about this on your own. So something similar to this, okay? It's a little bit more, well, think about that, okay? And we talk about this in the class. Alright, so we had the quiz, we are here now, we have one more, and we are done with chapter 5, and then we have a holiday break, okay? Objective, what did I say? 1 and 2. So these two are in 5 too. Okay, so here you go. Apply the definition and identify the special properties of a rectangle, a rhombus, and a square. Okay, so these are special parallelograms: rectangles, rhombus, and square. Rhombus and square. Okay, and determine when a parallelogram is a rectangle, rhombus, or square. Okay. Alright, so here's the definition. Rectangle is a quadrilateral with 4 right angles. Therefore, every rectangle is a parallelogram. Why? Think about why. But the definition is the rectangle has 4 right angles. Okay? The rhombus is a quadrilateral with 4 congruent sides. Therefore, every rhombus is a parallelogram. Why? That's a definition. Think about why. And the square is a quad with 4 right angles and 4 congruent sides. Therefore, every square is a rectangle, rhombus, and parallelogram. And think why. Okay? I think you already know the answer. Alright. Since rectangles, rhombuses, and squares are parallelograms, they have all properties of parallelograms. They also have special properties given the theorems on the next page. Proofs of these theorems are left as exercises. Okay, we're going to do the proofs as we go over. But just to clarify these special parallelograms, I'm going to put a Venn diagram here, okay? All right, so here's the all quadrilateral, okay, all quad. Inside here, this is a parallelogram, okay? So outside the parallelogram are any other quadrilateral that is not a parallelogram. So parallelogram is a special quad, right? And inside the parallelogram, there is a rhombus, and there is a rectangle. So why did I overlap here? Where is it gonna go in here? Yeah, this is the square. Okay, so square is a rectangle and a rhombus and a parallelogram and a quad. Okay, rectangle is a parallelogram and a quad. Rhombus is a parallelogram and a quad. Okay, and trapezoid is actually not in the parallelogram but inside the quad. Okay, Alright, so here are the three theorems. Diagonals of a rectangle are congruent. Diagonals of rhombuses are perpendicular. And each diagonals of rhombuses bisect two angles of the rhombuses. I wanted to prove these, but I think the video is going to get too long. So I actually want you to think about this. Okay, these are homework. Here's the diagram. Okay, so this is 512. Here is a rectangle. So these are all 90 degrees, right? And you have to prove that, let's see, A, B, C, D. You have to prove that AC is congruent. I'm sorry. AC is congruent to BD. Okay, so that's why this is what you have to do, and just come up with roadmaps. You don't have to write it. Okay, here's the rhombus. Four sides are congruent. You have to prove that. Let's see. This one is, let's call it math. MATH. Okay, so you have to prove that MT is perpendicular to AH. Okay, and last one was each diagonal of rhombuses bisects two angles of rhombuses. Okay, so 514. Here's another rhombus, and let's call this nice. Nice. All right, and you have to prove that these are congruent and these are congruent. Okay, let's call this O. Okay, so you have to prove that. Well, I'm not going to write it out for you, but you just have to prove this is congruent to this, this is congruent to this, and this is congruent to this, this is congruent to this. Okay, all right, here's theorem 515. The midpoint of the hypotenuse of the right triangle is equidistant from the three vertices. We did the problem similar to this, and I told you about like there's a problem that we end up saying that these are same lengths, and I told you that there's a theorem that's coming out later. So this is that one. Okay, the properties of rectangles lead to the following interesting conclusion about any right triangles. Alright, so begin with right triangle X, Y, Z and draw the line from the rectangle so that you draw X, Z, Y, K rectangle. So you just add another two sides to make it a rectangle. This is right angle, so if you draw a line that is parallel to this and parallel to this, these are all going to be 90 degrees, and draw ZK, and ZK is X, Y, Y, because this is going to be 90 degree or so it's parallelogram, so diagonals bisect each other, and X, ZK and XY bisect each other. Wait, ZK is XY, K is XY, but ZK is XY. So this one is coming from this, right? The diagonals of rectangles are congruent. Once you prove it, you can use it. So this is the 12. The diagonal of rectangle are congruent, right? And then the ZK and XY bisect each other. That's because the parallelogram diagonal bisect each other. And then MX equal MY equal MZ equal MK by 2 and 3. They are congruent and they bisect each other. So this is kind of like a paragraph proof. So these have to be the same lengths. Okay, so that's the 515. So the midpoint of the hypotenuse of a right triangle is equidistant from the three vertices. So this point is equidistant from this vertex, and this vertex. Okay, So that's 5, 15. And 15 and 16. If an angle of a parallelogram is a right angle, then the parallelogram is a rectangle. This is the warm-up that we did. If one is right angle, then all right angles, right? And if two consecutive sides of a parallelogram are congruent, then the parallelogram. Well, I'm giving away then. This was also warm-up. Okay, but so you have to interpret it and then understand it. All right, so let's do. I actually want you to do this one as a homework. Okay, so this is a homework. Okay, so I'm gonna do a couple lines. Okay, so you understand what you're supposed to do. Okay, so opposite sides are parallel. Is that true for parallelogram? Yes. And if it's true for parallelogram, the rectangle, rhombus, and square is going to be true also, because these are all parallelograms, right? You remember the Venn diagram? Whatever the characteristics of parallelogram is, apply to all these, because these are all parallelograms, okay? And so you have to know where the parallelogram characteristics ends and where the other ones starts. So for example, diagonals are perpendicular. That's not necessarily true for all parallelogram, not necessarily true for rectangle. It is true for rhombus. We've proven this in the theorem. And since the square is rhombus also, it applies for square. So I want you to try to figure out this, all of them. Okay, I think you can do it. All right, and then practice for 5.4. Name each figure shown that appears to be parallelogram, rectangle, rhombus, and square. I think you can do this. Name each figure that is both rectangle and rhombus. Both rectangle and rhombus means it has to be a square, right? So this you're looking for square. So the square would be what? Appear to be square, 2 and 9. Right. And you do 3 and 4. Name each figure that is rhombus but not square. So it has to be a 4 sides congruent but not a square. So it looks like 5 and 12. Yeah. Okay. Oh, yeah, sorry, you couldn't see. All right. I think 5 and 12 are rhombus and not square, and 2 and 9 are square. And you're doing each figure that is rectangle but not square. Okay, not bad at all. All right, I think you should do this for homework. Okay, so it's a little bit, but there are a lot in this packet, so you have to do more tonight. Okay, maybe I do A for you. F being equidistant from E and G, F is equidistant from E and G, must lie, F must lie on perpendicular bisector of EG, right? And so forth. Okay, so do the rest. And let's do 8. Angle KAP is a right angle and AM is a median. So median means this is midpoint, but we just proven in the theorem that in the right triangle, the median, the midpoint of the hypotenuse is equidistant of 3 vertices. So this is same distance. So MP is 6.5. Ooh, it's a combined number. We don't like it. Well, that would be 13 over 2. Right. 13 over 2. Right. And MA have to be the same. Right. You do 9. And let's do 10. Measure of angle K is 40. Oh, well, KAM. Oh, actually, so this is 40, right? And since these are the same length, this has to be 40. So K, A, oh yeah, so it's just 40. I thought it was asking this one. Anyway, all right. In the diagram below, the red figures are the ones inside, I think. These are red ones. These are red. Okay, can't see in black and white in the printout, but the lighter ones are red. Okay, red figures are formed by joining the midpoints of sides of quadrilateral. So these are all midpoints of the four sides. Okay, what seems to be common property of red figures? Describe how you would prove your answer to part A. All right, this is a good problem, so I want you to think about it. The hint is obviously this red is going to be a parallelogram. Question is why? How would you prove it? Okay, so this is homework. How would you prove red quad are parallelograms? Okay, and we are done.